Okay. So, by the way, this session will be recorded so that if you guys need to refer to it later on, you can. So, I, I realized I didn't start the recording. Apologies for that. But it's okay. We didn't miss too much. After all, it's just about myself, right? Who cares about me? As I was saying, I will be sharing case studies where things have worked out quite okay and where things worked out not so okay, right? And also, hopefully, this webinar will inspire you to think about how data can be used in your organization. So, what I won't be talking about because it's quite a, I think it's an entirely complex concept that should be handled on its own, which is how to structure data science teams. That itself is a can of worms which I won't open because talking about this requires an extensive treatment on the different ideas out there on how you can structure a data science team. So I won't be covering this, maybe another time if there's enough interest, right? Um, so the goal of this webinar for you, at the end, what I hope to achieve is to help you develop an understanding of what's required in an organization to use data science. You hear it everywhere, right? Oh, I want to use data for X, Y, and Z, or how can I use data? Hopefully, these scenarios and case studies ahead will kind of give you an idea. Um, yeah, again, to get inspired, right? So, without further ado, let's align ourselves on a couple of definitions. What is a prototype, right? A prototype over here, okay, I took this definition off Wikipedia because it's as good a definition as any, right? A prototype is an early sample model, built to test a concept or process. Now, in our case, a data prototype will be an early kind of like a model, right? Built to test a particular, to solve or address a particular business problem that an organization might have, right? Now, you might be wondering why prototype? Why not come up with a full-blown business unit? It's expensive to do so, right? And prototyping in general is a good way to validate a particular solution in a controlled manner, in a very constrained manner. You come up with a strike team or you engage a person to do it, right? But most importantly, right, actually the ingredient to success of adopting data products in an organization is convincing stakeholders of the value of using data. If you're a member of a company, you find it very hard if there's no proof of concept to convince, say, your boss or whatever. Or if you happen to own a company and you're a boss, right? You find it very hard to convince your one downs, your employees, about the value of data. So it's very important to get everyone aligned on that. And a prototype is one of the best ways, apart from data advocacy, right? Having someone in an organization to convince everyone the usage of data, right? Whatever. And furthermore, right, if you prototype quickly, you avoid overcommitting resources and time. And time is money, right? Time is opportunity cost. Or rather, if you don't use time wisely, that's a lot of opportunity costs incurred. So this is why we prototype. Now, another thing to get aligned on, so bear with me if you're familiar with this diagram. It's a very classic diagram from Gartner on the different kinds of analytics out there. Okay, hopefully you can see my mouse, right? On the left side, you have your descriptive analytics and diagnostics. So this is the realm of business intelligence typically. Take a bunch of data in a company's database and come up with reports and whatnot to explain what happened in the past. In the realm of data science, you have the right half, which is predictive and prescriptive. Predictive analytics would be to, for example, forecast, predict user behavior, fraudulent activity, so on and so forth. And prescriptive would be to come up, or rather to have a model to suggest things, right? Like, hey, why don't you optimize so and so, for example. So as most organizations tend to start off from BI and then eventually build capability for data science and whatnot. Now, also we hear this sometimes as well, data strategy, right? In an organization, right, it really depends on what kind of organization it is because it depends on the vertical it depends on the regulation in the industry as well. Let me give you two broad strategies that an organization would adopt. One is defensive and one is offensive. Now I'm just gonna highlight offensive because that's most of the stuff that I'll be talking about in this webinar. But briefly speaking, right, defensive data strategy involves minimizing business risk. What do you mean by that? Having a proper server, having a server that can store all of the data in a proper manner, right? Developing, so if you have a central database without scattered, say Excel sheets or whatnot, everywhere in your different business units, that's defensive because you're consolidating all of the different sources of data and all the data in your company. What could it be? It could be like keeping customer details, for example, right? You shouldn't be keeping them in a spreadsheet in different units in your organization. That's one. I think another thing would be like to ensure that your data, your server is free from any attacks. That happens sometimes as well. Malicious attacks do happen on your database. So building a defense around it would help you, right? So ensure compliance. So what kind of companies would have to adopt a defensive data strategy? Highly regulated industries such as, let me think, a hospital, for example. A hospital would have to be really sure that their data is kept in a secure server, right? So their priority would most likely be firstly consolidating all of the patients' data in a single location and also ensuring that it's free from attacks. Now, on the flip side, you have offensive data strategy, right? And that's something that most people look towards. So, for example, e-commerce companies would most likely take an offensive data strategy. Reason for that, because you want to increase revenue, you want to identify new segments in your customer base, right? So it's very customer centric, right? So usually activities around your offensive data strategy would be to create new products, services, right? For example, let me think what's a good one. Say if you use Zendesk, for example, let's say the big organization, Zendesk, actually you can use your customer complaints as a source of data as well. You can identify the common keywords that keep repeating in your customers, for example. That allows you to improve customer satisfaction, right? Or let's say, again, in an e-commerce context, if you see a lot of customers buying a particular item, you can then tweak that item's price point to improve revenue, for example. So most of the time when we talk about using data or like the exciting use cases of data, typically all lie in the offensive data strategy domain. So that's it. Despite that, in Harvard Business Review 3 years back, less than half of an organization's structured data is used, and less than 1% of unstructured data is used at all. Now, structured data would refer to tabular data, your Excel sheets, your SQL tables, and whatnot. Unstructured data will be, for example, emails that come in unstructured. They're all in pure text form, right? There's nothing much. Seemingly, there's nothing you can do with emails, for example. But if you gather enough feedback emails, unhappy messages through your different channels of communication with your customers, you might be able to mine something of it. So that's unstructured data. Unstructured data is notoriously very hard to work with. And usually you need someone with a bit of expertise in cleaning data or whatnot to do that, right? So last thing I want to share with you is the data science lifecycle. Generally, this is what happens, right, in a business that wishes to use data science for its business purposes, right? It's cyclical because, okay, one of the things that happens in coding education sometimes is we are led to believe that once you build a model, that's it. You just leave the model there. So you end up maybe stopping at modeling or model evaluation. People don't usually learn to deploy the model in an organization, nor do they stick around long enough for the model to predict things. and feed it back into business understanding. The sad truth about, okay, not sad truth, huh? The truth about model building, sometimes be it statistical, be it machine learning or deep learning, is that once you build a model of your existing data, right, that model starts becoming redundant once you deploy it, because you will have new business activity that's influenced by your model. That's when you have to tweak and whatnot. But never mind, that is a different that's a different topic altogether. Now, for a business to effectively prototype or utilize data, it really depends on how much infrastructure they have around this circle. You can have a business understanding. You say, okay, I want to use data to do X, Y, and Z. But if you do not have a robust data collection process, you're going to fail. If you don't have enough manpower to prepare your data for analysis, exploratory data analysis, so on and so forth, you're going to fail as well. So for successful data processes or even prototyping, you need to have a bit of each. Okay, the infrastructure to collect, people to prepare data, the ability to explore, right? To model this. In case there's a bug over here and you can't see because of the bar, what I'm pointing at right here is modeling, model evaluation, deployment. You must have the correct infrastructure, i.e. a proper database to deploy a model, right? So on and so forth. So enough pictures. Okay, no, enough framework, right? Let me share with you 4 different case studies. They're all very quick stories. Now, first case study is a project that I did with a primary school. Now, throughout the case studies, I will refer back to this particular model to show you why it's important to have all these different pieces in place, and what you can do with the data and how far you can take that data point, all right? So I had the opportunity to work with a primary school, and that primary school wanted to identify factors that correlate with students' performance, right? And so what was told to me was, hey, I want, okay, this is initiated by a head of department, and he told me, hey, I want to prototype a particular model, right, to predict the students' PSLE scores at primary 6. Now, for those of you out there who haven't gone through the local education system, the PSLE, right, is the exam that all students in primary 6 take, which is quite instrumental in getting them to the secondary school of their choice. So here it is, right? If you are able to predict a student's scores as early as you can, you'll be able to, I guess, intervene or come up with ways to help the student to improve his or her scores, right? Now, this was a particularly difficult project for me because of the following reasons. When we look at the available data resources in the organization, the results of the students, right, from primary 4 to 6 were stored in different places, and the head of department whom I was working with had to scramble all over the place to collect and to consolidate the data. So firstly, it is manual, right? And there's a lot of human factors involved. There wasn't any servers in place to store the data apart from the desktop scattered all over, right? Completeness, important indicators that usually correlate to student performance was unavailable. And what I only had were quite limited amount of data, limited in breadth. So I could only look at subject scores, right? And things like, I don't know, things like socioeconomic factors like that, those things are not available. But then again, you have to work within constraints, right? So if we don't have that, fine. Let's see what we can do with this particular data point. But most importantly, right, in terms of longevity, stakeholder buy-ins, we had uncertain buy-in from the principal and also from the other heads of department. On top of that, because of MOE regulations, it's very hard to work with data sets in schools. So if we go back to this particular chart over here, it's kind of hard, right? You have a good business understanding, spotty data collection. which also leads to how much you can prep your data for meaningful analysis. And by the time you reach to modeling, right, it's actually kind of the impact was quite limited with what you do. That's it, you see. So the boxes, the stronger the line, the more complete it is. We'll be looking at this for the other case study from here, right? Good business understanding, not so much on buy-ins. All the way modeling. By the time you reach modeling, it's already kind of not weak per se, but it's not as ideal as I like it to be. Okay. Now, so outcomes, of course, Jackie is Jackie, and Jackie always gets things done. We were able to come up with a descriptive model that could correlate subject performance and their PSLE final scores. We also identified the best time to help students with their subjects so as to improve. So primary 6 is where they take the test, right? So based on primary 4, 5, and 6, we somehow identify a particular point in time where we can help, right? That's it. I would say this project was a win because right, we then presented the findings to the principal and the other heads of department, and that got them sufficiently enthusiastic about improving their processes such that they can automate their data collection of the scores from then on. So in this case, right, the prototype that we came up with was instrumental in convincing stakeholders, one, and two, coming up very, would it be an actionable short-term win? Maybe, because there were students, there were existing students that can benefit from the model, right? But to see the outcome of this, we'll probably have to wait for another year or two before we can see whether this model was successful in helping students increase their scores. So follow-ups to be determined. Let's see how that goes. Now, at this point, here's some food for thought, right? You really need proper databases, infrastructure, be it some kind of SQL or whatever. SSOT refers to the single source of truth, right? In my previous example, what happened was your data was kept all over the place in different sheets, in different computers, right? And I didn't talk about the time the HOD took to gather all the different pieces of data, because on top of his teaching duties, he had to work on this. So it's juggling a lot of things. There wasn't any dedicated IT people available to help out, right? Stakeholder buy-in is very important. Without the initial support of the principal, for example, it was very hard for him to get data, even from other teachers, for example, right? So food for thought. So it's, yeah. Okay, so we'll move on to other case studies. Now, this is another startup I had help with. This one we didn't build anything, but was more of a consultative basis. But it was nonetheless, it's a good lesson for us. There are a few lessons that can be extracted. Now, here's the business problem, right? It's an early stage edutech startup that connects tutors to students via video call. So how it happens is you sign up on the website and you have video calls with a teacher on the other side. So this startup is not local. So it's to help students improve their English proficiency, be it grammar, vocabulary, so on and so forth. Those different aspects. The startup founder told me, hey, we collect all these video calls and we want to perform video analytics. Can I somehow use whatever video data I have and train a deep learning model? So okay, then I'm like, okay, cool. Let's have a chat about it, right? Let's have a chat. Now here are the available data and resources in that particular startup. The founder was pretty good. He had kind of like a vision of what he wanted. So from the start, when he implemented the website, he collected everything, every single thing. Website clicks, scores, everything, video sessions, everything. Anything that's tabular is kept in a SQL database, whereas something more unstructured like videos, I think it was stored on AWS. So everything was centralized, was good. And stakeholder, very determined startup founder. Now, business understanding is great, but he wasn't too sure on how to use his existing data in his database. Of course, when I prescribed, when I suggested things that he can work with his existing data, it became immediately obvious. But sometimes for a person in an organization, it's kind of hard to figure out what you can and cannot do with the data you have. That's why it's important to seek third-party advice, right? Um, in this case, you have robust. He had robust data collection, right? He had the infrastructure necessary to collect data from the server. Um, okay, this preparation should be in dots because he only has the data right here. Kind of a vague idea on how you use the data, and for this, he kind of stops because he doesn't have the manpower for it. Like he didn't hire any data scientists basically, right? So my advice to him was to work with what was existing in the database because he collected all of the students' scores and whatnot. The lowest hanging fruit he could do is actually just see which are the best performing teachers, right? Like teachers who help students improve the most, who, at least there's some analysis and he can start from there and try to figure out what makes good teachers great, for example. For the video, I actually suggested to him that he should look towards third-party APIs. So instead of using his own videos and training and everything, right, he should look at what's already available in the market. Usually those solutions are suited for someone without data team, for example. So my advice to him was actually to collect more data, right? Um, so here, therein, some food for thought. Sometimes look outwards for your data. I'll explain more later in my third case study. Don't just look inwards into what you have. Look outwards to see what other stuff's available out there, be it data sets, be it APIs, right, to augment what you can do. This is a advice that I usually give to a lot of startup founders, seed stage, maybe even post A sometimes. Post Series A startup founders, they are they are growing very hard and very fast, which also means sometimes coming up with a proper databasing, it's not a priority. In fact, I've spoken to very big companies before where they just keep simple sheets, Google Sheets for their work. Oh, sorry, give me a second. So give me a second, guys. Uh, okay, okay, Marco. Okay, Marco asked a question. That's a very good question. I will have a Q&A session later on where you guys can ask me questions. So Marco, hang in there. I will answer your question. It's a very good question. Awesome. Give me a sec. So what Marco asked is where can we find all these things? I'll show you guys later on. Oh, case study 3. Find My Life was my old startup. I thought this would be a good case study as well to think about. Okay, don't worry if it sounds like I started from some kind of random organization, and then now 2 and 3 are on startup. Last one is a proper SME. I promise. Just hang in there. Um, so my startup 4 years ago, right? What happened is I built a question answer platform to connect users to different financial planners based on the questions that they ask, right? Now, what I wanted to do is to improve the connection between the users and the financial planners, I needed to understand what they're asking. And the questions that were asked on my platform were free unstructured text. Um, so using simple algorithm to categorize the questions were relatively challenging. So as such, I turned to a deep learning model to categorize the questions. However, right, that's a challenge that a lot of companies face with. Like sometimes if you want to do a prototype like this, you don't have the data. What do, right? So in this case, the available resource is actually just a very small amount of tag question answer data, right? Stakeholder. So both my co-founder and myself back then, we were technical. We were both technical, and we both understood the importance. It's almost like a cornerstone in our platform, actually. So how we solved it was, okay, wait, this is how it looks like, right? We have zero everything else. We do have a server, but even then, that was what we have at that point in time. Uh, so what happened was we got creative. We scraped data from different sources, including our local and foreign competitors. In the end, at the end of it, after a quick, how long did I take to scrape? I think I only took a few nights, and I obtained 100K question answer label data set. That was a few magnitudes more than what I had in my servers, right? And a good thing about deep learning is that you can actually take an existing deep learning model and then perform and use transfer learning, which means you take a model, you take out certain parts out of it that makes it task specific, and you retrain that model using your own data set. It's a pretty neat idea, right? Sometimes you don't have to train from scratch. It's prohibitively so. So there's a branch of scholarship called transfer learning where you kind of like use one model, you repurpose it for your own purpose, right? So from there, right, we had a 95% question category prediction accuracy, which improved our matching of users to the right financial planners. So that kind of led to higher user satisfaction, right? So that's cool. And of course, to follow up from that, we managed to get more questions in, right? Native data, i.e. question that we did not scrape. And eventually we use our very own data to kind of like, eventually augment the rest of the model. So that was a win for us, right? So food for thought for founders, aspiring founders, people with limited database, no, with limited data in their database. Think about how you can creatively obtain um, data from various sources, especially if it's unstructured, right? Um, so yep, externally updated data is good data, but caveat, it's not sustainable. You can't keep scraping people's data. You gotta start using your own. Finally, ticketing. Okay, so this is our fourth case study. This is a huge project that we did last year. So the business problem for this was that there was a large regional ticketing company, right? So what they've been doing all along is they've been using business intelligence tools like Power BI, for example, and Quick. So they've been making reports and whatnot. But the CEO himself was interested in transitioning from just descriptive analytics to something to predictive, and he wanted to know how he could unlock the whatever data that he had. So we sat down, we take a look at what available resources that the company had. Um, Literally years of ticketing data stored on premise, right? So and there was a dedicated in-house IT team because they sell tickets through their e-commerce site, so everything's well maintained. An established business intelligence team, so it wasn't too far away from what they wanted to do, right? And stakeholder-wise, the CEO himself had a personal interest, right? And they were buy-in from multiple department heads that were relevant to this particular project. Of course, this is great because you can start all the way. You have all the necessary ingredients, right, from start to finish. And we just came in to help them do the modeling, evaluate, and deploy, right? They already had the infrastructure in place to deploy. So at the end of the project, we had what you saw as a predictive model that could accurately predict ticket sales, so much so that it was quite scary. But anyways, that was good. And we also deployed that model to provide daily predictions for a company. So from there, right, you managed to turn that whatever data they had into a product, right? Not just that. Um, what was exciting from that prototype typing exercise was that it it gave the stakeholders more certainty in pursuing this and adding more resources, which also led to the CEO hiring more data scientists to expand the product, right? That prototype was eventually, I think there are plans to kind of turn this into another revenue stream, right? Taking that predictions as a service, for example, for the ticket partners. So instead of food for thought, here's a recipe for success, right? There's already all these things in place which made it easier to prototype. That said, not saying that this company is better than others. It's just you have to really consider what's available in your organization, what's available outside, and what you can do, right? Um, so you have all this infrastructure as mentioned, stakeholder buying, exist, existing manpower, right? And this led to immediate and long-term business impact, right? And most importantly, this increased confidence in the management for further investment. Now, a quick kind of like a recap, right? Take-home message from this 4 case studies is that for business owners, as what I mentioned, if you're a business owner, make sure you have all the necessary ingredients to come up with a data product, right? For startup founders, try not to think along the lines of coming up with a product as your feature. Think about how you can address business pain points and then start and work towards your product. Um, that's the general advice that I give. So for those in innovation, I think it's preaching to the choir. I think you guys might know innovation better than I do. Yeah, just work closely with business units to articulate concrete, short-term and prototypable business problems, right? Problem discovery that can be addressed using data. Here's a handy checklist for you. This is a pretty good checklist because it kind of completes, it kind of involves all the different components necessary for prototyping. So again, ask yourself what the strategy is. Is it offensive? Is it defensive? Right? Something depends on your vertical really. Could go at length on that. Data, right? Are you capturing data properly, right? Properly as in, do you have automated processes, or do you like spend time copying data from one Excel sheet to another, or do you wait 3 million years for your data to load, for example? Um, Analytics, what kind of product will be helpful for your business problem? You can't just train a model and call it a day. Sometimes it can be something like clustering your customer segment, right, to discover new customer segments, or it can be prediction of whether a person will buy your product, or it could be recommender engines. But recommendation systems don't really work unless you have a bit of traction going. Either that, or you can leverage third-party APIs for recommenders. Implementation, can you execute it? Do you have the necessary resource, be it people or knowledge? Are you in the right vertical, right? Lastly, maintenance, right? Do you have resources to continuously implement it? What do I mean by that? As mentioned, models do not exist in vacuum. So once you're done deploying it, right, you need to make sure that it's continuously refreshed and it doesn't go stale, right? You need to like keep updating, which also means you need to maintain a kind of like a data science team. Or you can just throw interns at it every year, every semester. I don't recommend that. I'm not telling you guys to throw interns at it. It's bad because interns are there you don't want interns to struggle. Lastly, constraints. Of course, what are the limitations in the 5 points above? So those case studies that I shared, they kind of allude to that. So it's really a continuous process on understanding how you can navigate around these constraints. For example, let's see, let me think. If you don't have data, for example, point number 2, if you don't have data, you can always look outwards, scrape from, buy data from people, use an API, scrape, right? I'm not advocating scraping, I'm just saying scraping is one of those things that people do, cough, 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 right? Um, yeah, so stuff like that. Uh, well, thanks for your time and attention for this relatively short webinar. It's Q&A time. So I will, let me see. I think I will try to unmute you guys as well. So chat, let's chat. Let me chat. Okay. So Marco started off with a question on, can I recommend good sources to find such APIs, right? Open data set service providers. I guess the first starting point one would go for is, for lack of, I mean, I'm not being cheeky, right? It's really Googling. Googling actually helps quite a lot. Let me get out of this and, oops, okay, let me see if I can get out of this. Oh boy. Okay. Okay, I hope you guys are still on my screen. So, oh, please ignore my search. You know what I should be doing? I should be doing incognito for this. Wait, my screen sharing is paused. Okay, let me resume share. Oh. Um, sorry, let me stop share for a while and just show you what I usually do. Share screen. Okay, incognito. Man, I should clear my browser search. So the API that in case study two, right? In case study two, the guy wanted to use deep learning. So what I do is video analytics, pronunciation. Yeah, okay, boom, boom, boom. Video analytics pronunciation API. There we go, speech ace. So, okay, this is one place. Of course, another place that I would go for is Rapid API. Oh, Rapid API. Oops. Okay, API marketplace. This API marketplace has just about anything and everything you need. Just give it some time to load. Yeah, right. No, what's this? Oh boy. Okay, you know what? I'm not gonna log in here just to show you this is one of those places to find. Um, so that's one. I hope that answers. Of course. Okay, one more thing. I find open data sets. Okay, open. What am I doing? Open. I can't type. Oh my god. Open data set. Kaggle is a great Kaggle is a great source. Kaggle is a great source for you to find data sets. Of course, if you're local, if you're based in Singapore, I also highly recommend data.gov. Um, wait, oh, this is the wrong gov. Oh my god. Uh, there we go. I can't believe. Okay, yeah. Um, public data. Sometimes, even though everyone has access to the same data set, right? Um, it's what you do with the data that's more important, right? So, for example, I might be, let me think. I might be a Okay, I'm trying to filter out what I can say and cannot say because I work on so many different projects, different NDAs and whatnot, right? Okay, let's do this. We can. Let's say if I'm a ride-hailing app, let's say if I'm ride-hailing app and I want to keep track of all my different taxis available in Singapore, you actually have this nifty API that tells you at any point in time which are the available taxis in Singapore. So just gonna do a quick one. This API here retrieves LTA. So LTA maintains an API where you can retrieve data set from. So try it out, execute. Yeah. Go. Boom. GPS coordinates of every single taxis out there that's free. So yeah, so stuff like that. It really depends on what your business use case is. What do you mean by what do you mean by model deployment? How would you define a model? Okay, good question. Okay, so a model, right, is something that you build using what you have, i.e. data, right? In fact, uh, sometimes even a regression line is considered a regression model, right? What do I mean by that? We've been building model all our lives and you have no idea. Okay, regression model. Ta-da! Right, okay. I'm not being glib here. Okay, let me just... Now, this itself, this straight line here is what you call a model, right? In its most basic form. The reason for that is because this particular line here has been created by learning from the data points available over here, right? Um, this is a regression model. Of course, a machine learning model would be the decision tree model. Okay. I'm just trying to look for things that we can visualize easily. Um, this is very abstract also, right? Of course. Okay, wait, this is not good. Okay. I hope you guys can see it. Over here, this is a decision tree model where you are trying to figure out whether you should lend money to someone, right? Um, salary less than 5,000 is female. God, this is a bit of a problematic data set. Okay. Yes, lend. No, don't lend to males. Lend to females, right? If the salary is between 5,000, 10,000, then lend, right? So on and so forth. Um, Now, as for the question on what model deployment means, right? It could mean... Okay, wait, let me... contextualize this. Blah, 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 blah. It's all diagrams and whatnot. This is not useful. Um, okay, my favorite. I was having a webinar on this the other day. Now, I was teaching my students on... so usually when we do machine learning, for example, we'll train a model, right? And this is what it is right here. But usually to use it, to have it in a form that's usable, right? What do? You have to nest it in a server somewhere. You have to nest it in a server where you can use it, say, from a front end. So you have your user interface and whatnot, and from there you send data to the model. Now let me show you a project that my students did. Wow, this is all over the place. Okay, just give you a short moment. Just trying to... Okay, sorry, it's taking a while. Reason for that is we're on the... Come on, you can do it. I'm encouraging my... okay, cool. Well, there we go. Now, deploying a model means placing the model you have trained in a server somewhere where you can access it. So for example, over here is an example, right? I use this because this was built by one of my trainees. Here you have a song popularity predictor, and what it does is that you enter a song name and you'll try to predict whether it's a popular song, right? In the back end, the server of this particular site over here, there are the models that we have trained and with the respective accuracies and whatnot. It's pretty cool. Anyways, so what it's meant is that we've put this model to use, right? So this is how we deploy it. Hope that answers your question. All right. So thank you, Roger, for the question. Guys. Okay, it's a bit awkward. I think some people have. But okay. Basis, what's the basis for starting on the model? Are there any building blocks? Okay. Good question. If I'm going, so allow me to interpret this question a bit loosely. Feel free to chime in if my interpretation is wrong. Um, what's the basis for starting on a model? Like, I'm guessing what do you need to do to start building a model, correct? Yes, okay, correct. Well, traditionally, right, you need to be able to code, right? You have to learn Python, R, or whatnot, one of the languages that allows you to implement the machine learning libraries. But now I think as the data science scene improves, right, you have more and more solutions that do not require you to be a hardcore coder in order to build a model. So for example, what I mean by that, so Microsoft Azure, for example, drag and drop. So you have things like Microsoft. I keep saying Microsoft. Microsoft has a thing where it's called the Machine Learning Studio. Let me see if I can get a larger image of this. Uh, it's mostly drag and drop, building blocks. So it's a cloud service that allows you to kind of like, right, it's really drag and drop, and all these paths that you link, right, from one data point to another. Let me see if I can zoom in even more. Yeah, no, it doesn't work. Yeah, it sucks. Doesn't work. Okay, never mind. You start off with a data set, right? You define what your data is, and you can define the pieces. You see all these pieces over here: input, transformation, feature selection, so on and so forth. This is kind of like some of the things you can do if you really do not have anyone in your team to build a model. The pro is that it's friendly, right? Low barrier to entry. The con is that you kind of lose out on flexibility. Um, you lose out on flexibility in the sense that whatever you can do is kind of like constrained by the platform, right? Yep. Hope that answers your question. Okay. Yeah. Um, but as you move towards more serious deployment, it's usually a good idea to have people who can. You see, okay, wait. It's cool, right? You can even see like there's Python language modules, R language modules, OpenCV. This is computer vision, right? You have machine learning, so on and so forth. Am I advocating for such platforms? Not really, but it is an option you can consider. Okay, please keep the questions coming in. It's how do I get it labeled? Ah, okay. So Roger asked how I got my 100K rows of data, right? How do I get it labeled? Now, generally what happened was for some of the places that I scraped for category, right? Because I was predicting for categories, um, okay, this let me think of what were the you know what, I don't have them anymore. So what I did was I would go to websites that had forum conversations, for example, and I would scrape. Now those forum conversation examples are great because they're already pre-labeled. Because usually for those forums, for example, they do have kind of like a category there. It will kind of like say, oh, let's talk about something insurance, and then you have all the questions related to that something insurance. So that was kind of like easy labeling. Of course, we employed things like semi-automatic labeling techniques as well, but that was so much later when we gathered enough data sets. So to also answer your question, sometimes you do not need to label you don't have to explicitly label your data. Sometimes you have automatic labeling libraries as well. Uh, you let the machine learning model come up with its own label. Sometimes the labeling works, no, sometimes the automatic labeling works, it makes sense, and you can intuitively kind of like give a proper label to that. If not, then, you know, then it's just pasta, right? One of the places that we went was a competitor of ours, and eventually we acquired them because we did so much better. Anyways, so that's that. Yep. Oh man. Okay. Okay, like I shan't force you guys too much. Okay, let's go back to my presentation just a bit to end. Oh, no, not this. Okay, let me stop sharing and go back to my notes. No, not my notes, my presentation for wrap up. Share screen, share screen. All right, okay. So we've almost come to the end of our webinar, right? It's 6 o'clock, 1 hour as promised. Please feel free to reach out to me if you want to have more conversations regarding data science. UpLevel does a couple of things. We help, okay, wait, let's start off with, of course, the reason why we hold this is because we have experience in helping companies prototype. We consult a bit, right? But most of the time we would prefer actionable outcomes, i.e. a model and whatnot. We help companies find talent through our train to hire program, right? We help prototype, and yeah, we just do, these are the two business activities that we do. Of course, happy to always talk about how we can help you in your data science process, right? Yeah, so feel free to email me, Telegram me, or WhatsApp me, WhatsApps. Yeah. So on this note, thank you everyone for your time and attention. I'll be hanging around for the next half an hour. I'll be unmuting everyone so we can turn this into an unruly chat. Wow, okay, I don't know if that's a good idea. Okay, wait, I will mute all again, but I will allow you guys to unmute yourselves if you want to say something. Oh, that was bad, sorry about that. Yeah, I'll be just here for half an hour chilling. Please feel free to ask me questions. I'll be sharing memes as well, and also to provide you context behind each meme. I love memes, so if you love memes, hang around, all right? Okay, thank you everyone. I will also be sharing feedback form to you guys, so please keep an eye out for that, just to see what you guys are interested in for future webinars, for example. All right, thank you, take care, stay safe.
Just a question, Jackie.
What's up?
You mentioned about transfer learning teaching.
Yeah.
Do you have any articles or any, could you point me in the right direction to learn about that?
Sure thing. Drop me a Telegram. Happy to share some resources. Actually, I have no idea who oh yeah. Sorry, if you sound out, I wasn't sure who was speaking, so I didn't know how to address you. Okay, ping me like right now so I can share you some resources. Okay, well, I'm just gonna like go through some of my favorite memes with you guys. Okay, this deserves a whole full screen treatment. Whoop.
Hi Jackie, sorry, can I ask a question? I asked you the question just now as the basis of starting on a model.
Yes.
But I guess what I was asking is even not so much skill based, but I think you mentioned there's a cycle, right? You need to collect some data and stuff like that. I guess what I'm saying is that not so much skills, but what do you need? Must you investigate what data you have before you start building? Do you need some hypothesis? Or are there couple of entry points?
Okay.
Yeah,
So,
that's yeah.
okay, thanks for clarification. Entry point will be usually you must first and foremost start from a business problem. What do I mean by business problem? Could it be like, okay, let's say from an e-commerce company, that's actually the easiest example. How can I better identify the customers that I want to serve? That's maybe the starting point. So you dig in, right? So you dig in, you look at let me think, your say purchase data, for example. You export the sheet to see who's there. Hopefully you can get the age, you can get the address. Sometimes even address, okay, this is completely internal, right? Which also means that's something you can work with, as long as you don't send them crap. Then you're like, oh, okay, I have address. I have address data. From there, can you kind of like identify the segment of customers that live in a particular zip code area, for example? That's one. So to answer your question, I think always start from the business problem. I hope that
Sure. I think I mean, okay, so you have the business problem and you have this data set that you may have had. It's maybe a bit messy. It has incomplete data because it's like your first time starting on this problem, right? Let's use your example. So
Yep.
then what do you do after that? So you have the names, you have customer CRM database, you have some information about customers and their purchases, and then you are trying to answer that problem. So do you make some assumptions? Do you test that existing data set for assumptions first, or how do you get from there, I guess, to model?
Okay, good question. Perhaps I can share a case study that I didn't share earlier. We were helping a local charity with understanding the data. So they had, I think they had like 5 digits worth of customers. So they had a whole CRM and whatnot, right? So we told them, okay, export your CRM, give us everything you have, and we work with them. Now, but even then, they meaning that charity, right, already had a defined idea of what they wanted out of the data. So starters, we usually do exploratory data analysis, or rather we clean the data, right? We clean the data to see how much insights we can get out of it. Data was structured okay because it was a CRM. So we kind of like drill down, right? Hypothesis, we didn't really. Oh, okay. We did have a hypothesis, which regards, because when we look at different columns of data available, for example, is age. One of it was age, and we hypothesized, okay, does a particular age group donate more often than another age group, for example? The answer was answered when we looked at the data, so we had to come up with like plots and shit. Then we moved on to, those are more exploratory, right? It's like it's descriptive analysis. Then we moved on to assessing whether it was suitable for machine learning. Is it enough data? Answer is yes. Do you have any let's see, do you have the crucial metrics, for example? Crucial metrics meaning, okay, I have age, I have gender, I have so all these things are actually informed by domain knowledge as well. It's a very to build all these things, it's kind of like quite reactive as well. You really have to sit down and look at what data is available before making the call whether to proceed into modeling. For that particular project, we told them, okay, your data is good enough for descriptive, but not good enough for machine learning modeling because there wasn't much we can derive out of that.
Okay, so then it's good enough for descriptive means you have, let's say, okay, you know that in this zip code, there's higher purchases, for example, right? So you looked at the trends that you could see just based on the data set that you have, right? So now, does it mean that, let's say you only have this, okay, cannot do machine learning, but then you can start doing a model so that you can eventually get to machine learning, or no? You have to collect more data first. I guess I'm trying to think where's the breaking point of like, you have this data set, do you need more data before you can start doing a model, or can you, with that descriptive level, you should start first, and then while starting, ingest the data from that new process, right?
Okay. So our advice for them was to collect more data points, not just whatever they had. So to expand the number of columns they have, basically. And I guess the idea is to revisit this maybe in a year or two to work from the expanded data set and not from the old one.
See.
Yeah,
Okay.
yeah. So we think, yeah. So we gave them what we thought was important and necessary for their future data collection efforts.
Right.
It takes a while.
And based on the descriptive nature, were they able to implement some business changes?
Yeah, they did. They
Okay.
did. Yeah,
Okay.
yeah. That was good because I guess this was shared with the marketing team. Oh yeah, wait, what's the buy-in? CEO approved it, but we worked directly with the heads, so that was good. So that led to, I hope they're gonna implement. One bad thing is that sometimes when we do all these projects, right, we don't stick around to see if it has any long-term effect. Hopefully 1 or 2 years from now we can probably reconnect with them and see how it went. So following up is important.
Right.
Yep.
See.
Okay. Yeah. Thank you for that question.
Thank
Guys.
you.
Yeah. No worries. Okay, guys. If you're wondering what this meme is, right? This is funny because I like it because a lot of data scientists have this idea that if they throw if they train a model directly, right, they can actually come up with a useful model. Sometimes domain knowledge not so good implementation beats a very good implementation without domain knowledge. I come from a background where, okay, my old background was in biological sciences. When I was working in a wet lab research, right, we used to collaborate with dry lab scientists. Dry lab meaning like bioinformaticians. Bioinformaticians have this idea that, okay, all we need to do is just crunch the genomic DNA data and just come up with insights. And then you guys meaning the wet lab people, go ahead and work on it. The problem is sometimes without proper domain knowledge, what happens, they end up giving recommendations such as, oh, okay, you'll have to, okay, this is dramatized by the way, but it's along the effects of this. Hey guys, we've gone through the genomic data, and I think to evaluate your brain cancer question, you'll have to look at this gene that controls nose hair. Okay, it's not that funny, but it was quite bewildering why they would recommend that, but shouldn't, right? So you're always start with a business question and see where you can move from there. One of my favorites. Oh, it's this question. Yeah, I work with models. I wish I worked with the models on the left, but unfortunately, my life is on the right. Yeah, that's what happens. But anyways, so that's cool, right? Be prepared for that. Right. Oh, what's this? Okay, so last thing before I guess. Wait, what time is it? We still have time. Feel free to ask me questions in the meantime, right? Right here is an interesting thing, right? A combination of two of my favorite things, deep learning and memes, right? So this particular research team trained a model that auto-generates captions for memes, right? So, and the seed for this text generation was in the input tweet, please save the world from corona. And what the model decided to do is to generate such captions. What's worse for, this is my favorite, what's worse for corona? I'm in the world to save it. It's ridiculous, but yeah, it's okay. On a related note, I ran this project where we scraped the entire hardware zone, right? I hope you guys go to hardware zone because it's an amazing place, right? That's an amazing place. What my trainee and I were doing were we scraped the entire EDMW hardware zone, and we built a model. Oops, what's this? We built a model that could generate Singlish phrases. Does it have any use? No. Was it interesting? Yes. What would we do with such a thing? I don't know. Come with a Bing chatbot. Who knows, really? So anyway, that project was shelved in cold storage simply because that project came out of more of a curiosity standpoint. Like, are we able to come up with a text, with a model, a deep learning model that could generate Singlish? Answer is of course yes. Yeah, that was last year. I wonder what we should do with the data. Shit. Oh well. So that's that. Okay, no more memes, unfortunately. I should have searched for more. A bit of context about this, right? It happens quite often. You'll be surprised on Facebook, on Kaggle, on all kinds of, and even Twitter, really. Dunning-Kruger, what can I say? Okay. Let's see. Okay, this is a relatively quiet place. I guess if there's nothing else, I could. Oh, what's this? Able to give an example of how data product POC to proof of. Okay. So BH Tan here asked an example. I guess I understand that you came a bit late. Actually, I did share about that in case study 4. Don't worry, later you'll be able to revisit this once I process the video for you guys. No worries. So keep an eye out for it. BH Tan, Mr. Tan, right? Or Miss Tan. No worries. It's you came late. That's fine. But in short, what happened was POC involved working with a ticketing company to predict ticket sales, basically, and we put it into production. We posted that model to do daily predictions in the server. So it's kind of like spit out a CSV file every single day, basically, and then the business intelligence fellows can look into it. Okay, the crowd is thinning. That is that. Keep in touch, everyone. Keep an eye out for more emails and whatnot. Okay, I shall end this right now before my computer runs out of space for the recording. Ha, 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 ha. All right, take care, everyone. Stay safe. I shall end the call. Stop sharing. Bye. That's so kind. Thank you. Okay. All right. Okay. So, all right. Bye bye. Okay. Okay. Bye, everyone. I'm just gonna kick all of you out. No. Okay, please. Thanks, Ramanathan. You're very nice.